Testing for calcium and total hardness, featuring Taylor's K-1514. Who should use this kit? When water percolates through rocks and soil, it picks up minerals such as calcium and magnesium. The sum of these calcium and magnesium ions that are present in water constitute what is considered total hardness. Although hard water is safe for cooking, drinking, and other household purposes, high levels can cause serious problems for boilers, cooling towers, commercial laundries, and other processes. Calcium hardness is an important parameter to watch because it can form scale at more neutral pH levels, whereas magnesium generally requires higher pH levels. Hardness scale reduces operating efficiency and can lead to premature equipment failure. For these reasons, calcium and total hardness are often tested in water to assure system reliability and water treatment program performance. It is critical to test water hardness on a regular basis, and Taylor offers several kits to help you monitor this parameter. For this demonstration, we will be using K-1514, a simple drop test for determining calcium and total hardness. The K-1514 allows for two equivalencies. 1 drop equals 2 parts per million, and 1 drop equals 10 parts per million hardness as calcium carbonate. We will be demonstrating the 1 drop equals 10 parts per million method in this video. Unlike other manufacturers' test kits that may produce a very subtle change of color at the endpoint, the distinct change from red to blue is easy to recognize using Taylor's K-1514. Note, if you are testing hardness levels below 5 parts per million, we recommend using our Trace Hardness Test Kit, K-1504, for improved accuracy. Metal ions may cause interference in the test for calcium and total hardness. If your sample reaches a blue endpoint, but then slowly reverts to red, this is an indication that metals are present. To prevent this interference, add 2 or 3 drops of hardness reagent, which contains EDTA, to your sample before adding the buffer and indicator. Then, test as normal, making sure to count the drops of titrant added initially to the total required to reach the endpoint. If interference still occurs, dilute the sample with DI water as necessary and retest. Before beginning this or any other Taylor test, it is best to read the instructions through to the end. Familiarizing yourself with all the steps to come is particularly important if the test is new to you or if the kit is newly purchased, as sometimes our procedures change. We will first perform the calcium hardness test. The water we will be using for our test is the makeup water for the Baltimore City area. Rinse and fill the 25 ml sample tube to the 25 ml mark with the water to be tested. Taylor's sample sizer, shown here, is a great tool for getting accurate measurements every time. Holding the bottle vertically, add 10 drops of calcium buffer and then swirl to mix. For this demonstration, we are using Taylor's Speedster, which is sold separately, but you can also manually swirl the sample. Add 1 level dipper of calcium indicator powder. Swirl to mix. The sample will turn red if calcium hardness is present. Next, add hardness reagent dropwise, swirling and counting after each drop until the color changes from red to blue. Multiply the drops of hardness reagent needed to reach the endpoint by 10 and record as parts per million calcium hardness as calcium carbonate. Discard the sample and rinse the sample tube with DI water or hardness-free water before performing the test for total hardness. Next, we will perform the total hardness test. Fill the sample tube to the 25 ml mark with the water to be tested. Add 5 drops of hardness buffer and 1 level dipper of hardness indicator powder. Swirl to mix. If hardness is present, the sample will turn red. Add hardness reagent dropwise, swirling and counting after each drop until the color changes from red to blue. Multiply the number of drops of hardness reagent needed to reach the endpoint by 10 and record as parts per million total hardness as calcium carbonate. Finally, to determine the magnesium hardness in a sample, simply subtract the calcium hardness result from the total hardness result. With a total hardness level of 140 parts per million and a calcium level of 110 parts per million, the magnesium hardness is 30 parts per million. For discussion purposes, let's assume we tested a cooling water and found a total hardness level of 560 parts per million and a calcium level of 440 parts per million. In this example, the magnesium hardness would be 120 parts per million. The magnesium hardness is useful to know as at neutral pH levels, it is more soluble than calcium. For most open cooling water systems, the value found by dividing the cooling water magnesium level by the makeup water magnesium level often approximates the number of cycles of concentration in the system. If this value is similar to that found when dividing the cooling water calcium level by the makeup water calcium level, then you can be reasonably assured that your system is not forming calcium scale. However, if the value from the magnesium calculation is noticeably higher than the calcium calculation, then the system may be experiencing calcium scale formation. Suppose the total hardness in the previous cooling water example was only 520 parts per million, and the calcium hardness in the makeup water we tested was 400 parts per million. Then, the magnesium hardness in the cooling water would be 120 parts per million. If we calculate the cycles of concentration for each hardness species, which is referred to as performing a hardness balance, we would find the total hardness cycles to be 3.7 cycles for total hardness, 3.6 cycles for calcium hardness, and 4 cycles for magnesium hardness. Since the calculated cycles of concentration are lower for total hardness and calcium hardness than magnesium hardness, this could be an indication that scaling is occurring within the system. In addition to K-1514, Taylor offers several other kits for determining hardness. K-1503 for testing total hardness, K-1504 for testing total trace hardness, K-1567 for calcium hardness, and K-1594 for calcium, magnesium, and total hardness. Taylor's knowledgeable customer service representatives are available to provide technical assistance about our products. call 800-TEST-KIT.